Hi, everybody. So first, just want to say welcome to grade 6 math. I know that this is technically the second video that you're watching, so it's not really the first one that you're seeing, but it's the first one I'm recording this year for you, as the first video you watched was recorded last year for the last year grade 6 class. So this is our second video. I'm going to go over in detail what you guys will do with this as soon as we move on to the next unit. But for now, I'm just labeling what video we're on so you know which video you should be watching, whether it's first or second. And I'm labeling what it is. So we're going to be adding and subtracting fractions in this video. And our learning objectives, this is what you should be able to know how to do by the end of this video. Now, you don't need to master it, but you just have to have an understanding of what it is that we're doing. So this way, when we are back in school, you can come in with questions or have an expectation of what we're going to be learning in class or doing in class. So the first thing that we're going to be able to do by the end of this video is know how to add and subtract fractions with like denominators. So that's the key word there, that they are like denominators. And then the other thing that you're going to have to know how to do is add and subtract when they are unlike denominators. So you're going to have to be able to know, what does it mean when something is like denominators, or what does it mean when they're unlike denominators? All right. Before we get started into anything, one of the common mistakes I see when we're adding is that when anyone sees fractions, when we say like denominators, that means that our denominators, the number in the bottom, are exactly the same. So in this case, they are like denominators because they're both 2. So what people do is, once they see that they're like denominators, because in multiplication we end up multiplying our numerators and denominators, they think the same thing happens with adding. And they will just add the numerators, so 1 plus 1 will give me 2. And then they'll add the denominators and get 2 plus 2 is equal to 4. But we know that this has to be wrong, because if we think about it, 1/2 of something plus 1/2 of something should equal an entire whole, an entire piece of it. So this is 2 over 4 is not an entire whole. So we know that this cannot be right when we are adding and subtracting fractions. We don't have to add both or subtract both. So we're going to go over in this video, well, what is it that we do? So if you're making this mistake, which some of you were in the pre-assessment that I gave, just remember, it's not exactly the same like multiplying. There is a huge difference of what we do. So we do not add both the numerator and the denominator like we would when we're multiplying. All right, so let's go ahead and go through some problems and talk about what it is that we do when we are adding and subtracting fractions. There are 5 problems that we're going to go through in this video. All right, when you are looking at a problem, the first thing you should do is identify, well, what operation are we trying to perform here? So in this case, we are adding. And when we're adding, we have to have like denominators. So the first thing we're going to do is we're going to look at our denominators. In this case, they're both 11. So yes, we can put a check mark next to this to say, okay, we have like denominators. And when they're like denominators, it is super easy. All we do now is we are going to add the numerator together. And all we do is we just take our denominator and we just write it as is. So 3 plus 5 will give me 8. So it becomes 8 over 11. So all we're doing in this case is we're simply just performing the operation on our numerator. All right, when we are adding our fractions, what our denominator is telling us is how many pieces we need in order to have a whole. So it's how many pieces this is broken up to, how many parts we have. I guess I should be saying parts, not pieces, but it's how many parts we would need to be able to make up a whole. So it's saying that this is 11 parts is what it is making, is what we would need to have a whole. And our numerator is telling us, well, how many parts do we actually have? So here we see our denominator saying, well, 11 parts or pieces will give us an entire 1 piece or whole. And here we have 3 pieces. And then on the other fraction that we have, it's telling us how many pieces we have. We have 5 in our numerator, and the 11, the same thing, is telling us how many we need to make a whole. So since we're breaking this out into 11 pieces, our denominator will never change. It's always going to remain 11 when we're adding or subtracting. Once we get them to be like, it's always going to remain at 11 because it's saying how many parts we need to make a whole. And then that's why we're only adding our numerator, because we have 3 parts here and 5 parts here. So how many parts in total do we have? Well, 3 plus 5 gives me 8. So it's telling us how many parts or pieces we have out. It's telling me how many parts or pieces we have, and then the denominator is telling us how many parts or pieces that we need in order to make one whole piece. So that's why we're only adding the numerator, because that's telling us how many we actually have, or how many parts we have in this case. All right. If this is confusing you at all, please write down your question and bring it to our first Zoom video, our next Zoom video, so we can discuss this. But the common mistake that we see is that people just add it all together and they want to say it's 8 over 22. But remember, when we're dealing with fractions, when we're adding or subtracting, we don't actually add or subtract the denominator. We only add or subtract the numerator. The denominator is going to remain the same because it's telling us how many parts or pieces that we have or that we would need in order to make a whole. All right, so then for this next question, let me put number 2 here. I should be numbering these. So the first thing that we do is we look to see, do we have like denominators? That's the very first thing that we're looking for once we see that it is a plus or minus. That's our operation. So do we have like denominators? Yes. In this case, they're both 5s. So once we have like denominators, nothing changes with our minus. It's not that all of a sudden we're going to do something crazy. What we're going to do is we're going to actually just look at our numerator and we're going to perform the operation just to the numerator. So it becomes 3 minus 2 and our denominator doesn't change over 5 because remember the denominator is saying how many parts or pieces we would need to have a whole. And if we have 3 pieces and we're removing 2, well, what do we have left? We have 1. So that means that this would subtract to give me 1 over 5. And that will be our final answer for this. So once they're already set up that they have the exact same denominator, it makes it super easy for us to add or subtract, and we just do that with our numerators. All right, now we're going to move on to a little bit harder questions where their denominators aren't going to be the same. What do we do in that case? All right, so for this one, for question number 3, we have 1/3 plus 5 over 18. So we identify what operation are we doing, because if this is multiplication and division, it's super easy. We don't have to worry about finding common denominators. So then we look, okay, we know we're adding. So do we have like denominators? It's the very first question that we are always asking ourselves. In this case, no, we don't, because 3 and 18 are not the same. So we know that we do not have like denominators. So what we need to do is we need to change these in order to get like denominators. This is our goal. We need to have the exact same denominator in both these cases because we need to make sure that in order for us to have a whole piece, they need to be broken into equal parts, meaning that we need to have the denominator to be exactly the same. So we can manipulate. You're going to hear me say this all the time throughout the year. Manipulate. We can change our fraction so that it does give us a common denominator. And what we do is we look at 3 and 18. All right, this one, 3 and 18. We look and we go, okay, let's find our multiples. So we look at this 3 and we write out all of our multiples. So 3 times 3, 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 12, 15, 18, 21, and so on. And then we write out our multiples of 18. We have 18, we have 36. I'm going to stop here because once we see that both of these numbers, that both of these denominators, they have a least common multiple or the exact same multiple, that's our number that we're going to use. So we see that 18 appears in both of these. So once we identify that, says, okay, that's what we're going to then change our denominators to. Well, luckily, this one's already changed to 18 or already is 18, so we don't need to change it. So I'm just going to go ahead and leave that, highlight that, because we're leaving that as is. Then we need to change 3 to 18. Well, we need to ask ourselves, because we're going to multiply here. 3 times what gives me 18? Well, 3 times 6 gives me 18. So I know I need to multiply this 3 by 6 in order to change it to 18. And what we multiplied to the denominator, we have to multiply to the numerator, because what does 6 over 6 actually equal? It equals 1. So anytime we multiply any number on the face of the earth, and I'm just going to represent that by n, and we multiply that by 1, it is always equal to that number n. A 1,205,000 times 1 is still 1,205,000. So nothing changes when we multiply it by 1. So that's what we're doing here. We're essentially multiplying it by 1, but we're rewriting it in a way that it can change and manipulate our fractions. So now we multiply in. 6 times 1 gives me 6, and 6 times 3 gives me 18. So now we look and see, okay, we do have our common denominators, and this is called our least common denominator when we look for the lowest value that they share. And once we have that common denominator, we know that we can simply just perform the operation only to our numerator. So I can then say 6 plus 5 over 18, and now 6 plus 5 gives me 11 over 18, and that is my final answer. All right, we're going to start moving. We're going to do one more. It's a little bit easier, and then the last one's going to be a little bit harder where there's one more step at the end. All right, let me just go ahead and move on to the next problem. All right, so for this next one, first thing we do is we identify the operation. It's a subtraction. So now we know with subtraction or addition, we need to have common denominators, or are they like denominators? In this case, no, they're not. So we're like, okay, we have to find that. So now let me just show you how you should write this out maybe a little bit better next time. So when we're finding our least common denominator, we're looking at our two denominators, and I'm going to put this 4 colon and 3 colon. All right, because then I'm representing what they are. And then I'm going to write all of my multiples of 4, and what that means is we're just simply going to go through and multiply 4 times 1, 4 times 2, 4 times 3, 4 times 4, and so on. Once you guys get the hang of this, you won't need to do this, and some of you won't need to do this as well, but if you're struggling with finding least common denominators, writing them out like this can really, really help. And then writing our multiples of 3 will be 3, 6, 9, 12. I'm going to stop there because I noticed that I had already written 12 for 4. So that is the least common multiple that they share. It means it is the smallest multiple of each number that they share. You can always use larger numbers, but if you use something that's not your least common multiple, you will always, always, always have to reduce at the end. So that's the only difference, the only trouble that some people may have with this. So now, I need to multiply 4 by what to give me 12? Well, I know 4 times 3 gives me 12. What I do to my denominator, I have to do to my numerator because I know 3 over 3 is actually just equal to 1. Then I ask myself, well, 3 times what is equal to 12? Well, 3 times 4 gives me 12. So what I do to the denominator, I also have to multiply to the numerator because 4 over 4 is 1. So we're not changing the value of any of these. All right, so 3 times 3 gives me 9. 4 times 3 gives me 12. Minus 2 times 4 gives me 8. And 3 times 4 gives me 12. Once I have those common or like denominators, I know all I need to do now is just perform that operation to my numerator. So since we're subtracting, I can do 9 minus 8 over 12. And 9 minus 8 is equal to 1 over 12. And that will give us our final answer. All right. If you were to use another number, so let's say that you're going to use 36 for your least common multiple, that's fine. You'll still get the right answer, but you're just going to have to reduce at the end. And we're going to go through the next problem of how we're going to reduce at the end, like what we should be looking for when we finish our fractions. Okay, first thing I do is I identify what operation we're performing, because if it's multiplication or division, we just multiply or divide. But it's addition, so I need to look, do we have like denominators? And no, we don't. So I know that right away, okay, I need to make them like. So when I look at these, I'm not going to write my least common multiple out for them because I should be able to identify, well, 5 goes into 15, so that means 15 is going to be our least common multiple because if one of our denominators can go into the other, then we know that that's the number that we're going to use. So we're just going to ask ourselves, okay, so 5 times what gives me 15? Well, I know 5 times 3. So what I do to the denominator, I have to do to the numerator because remember, 3 over 3 is 1, so it's not changing our value. Then we multiply. 3 times 4 is 12. 3 times 5 is 15. And we have 6 over 15 here. All right, so now, once we see that our denominators are the same, I can then combine or perform the operation on my numerator. So now we have 12 plus 6 over 15. All right, so 12 plus 6 is equal to 18. And now we have 18 over 15. Now, this is where some of you are making your mistakes on your pretest that you submitted to me. You would stop here. Right? You are really, really, really close of getting this correct. But anytime we write fractions, especially when we're given it as an answer, we always have to simplify it as much as we can. All right? We don't leave it unsimplified. So we need to ask ourselves, just like we did in our last video that you're watching, we look to simplify. Are there any numbers that multiply into 18 and that multiply into 15? So hopefully this can identify to you that, yes, both of these are divisible by 3. So what I can do then is divide both of these by 3. And because I'm doing the same thing to both my numerator and denominator, just like we're here, we're essentially just changing this value, but we're then only dividing, essentially we're multiplying this by 1 again, but it's allowing us to reduce it so that this way we can get what our most simplified version of this fraction is. So 18 divided by 3 is 6, and 15 divided by 3 is 5. Right? On any question you answer for me, because none of your standards say you have to be able to write from improper to a mixed fraction or mixed number. So in this case, you can always leave your answers as improper fractions if you want. Or if you want to write this, you can then say, well, how many times does 5 go into 6? Well, it goes into it 1 time. And then we would have 1 remaining, so it'd be 1 and 1/5. Either way, both of these are correct. I would accept either of these throughout the entire year. If you want to leave it improper, change it to mixed, I don't really care. It's your call. All right. I would say leave it as improper, actually, because when you guys get to higher level maths, you're going to see that we do leave them as improper the overwhelming majority of the time. Um, and also, if you're trying to change it to a mix, you might make a mistake somewhere in your calculations, which then cause you to lose a little bit. All right. So this is it for this video.